In this video, we're going to look at some additional simplifying techniques for our trig functions using our fundamental identities. And we're going to look at some algebraic techniques that we didn't explore in class today. So one of the algebraic techniques we can work with is when you have two expressions being multiplied together. Obviously, just like you were taught to simplify in algebra, we can go ahead and FOIL and multiply these two groups together. So we would start by multiplying the first terms together, and 1 times 1 would be 1. Then multiplying our outer terms, we would get negative sine x. Then multiplying our inner terms, we would get positive sine x. And then multiplying my last terms, I would get negative sine squared x. Now, once I have all of these terms, just like in algebra, we would go ahead and combine any like terms. And in this case, we can see the negative sine x and that positive sine x would actually cancel, and we'd be left with 1 minus sine squared x. Now, what we also want to remember is that when we see these ones and these squared trig functions mixed together, a lot of times it's a good idea to go and check our Pythagorean identities and see if we can rewrite any of them and simplify this even more. So our Pythagorean identity says that sine squared theta plus cosine squared theta equals 1. And again, we can go ahead and rearrange these guys. So if I want 1 minus sine squared theta, I can subtract that sine squared theta over there, and I can find out that cosine squared theta is the same as 1 minus sine squared theta. So I can go ahead here, and just instead of stopping at 1 minus sine squared x, I can actually go one step further and say that that's equal to cosine squared x. And that would be my simplified form for this answer there. So that's one of our techniques that we can do. We can go ahead and we can FOIL and multiply some binomials, just like we did in algebra to simplify expressions. And then the next example is going to be something a little bit strange. Normally, when working with fractions, we try to take two fractions and merge them together by finding a common denominator. And we create a simplified expression as a single fraction here. But when we're trying to simplify using trig identities, sometimes what we actually want to do is unadd or unsubtract our fractions here. So what I mean is that we want to basically break apart this back into the two functions that would have been added together. So originally I would have had that numerator tan x over that denominator, and then my plus sign, and then I would have had sine x over that denominator. So I'm basically separating this fraction back into the two fractions that I would have added with that common denominator of sine x tan x. And once I split them up, I can see here that the tangents would cancel, and I'm going to be left with 1 over sine x. And using our reciprocal identities, 1 over sine x would be cosecant x. And then over here, the sine x would cancel, and I'd be left with 1 divided by tan x. And using our reciprocal identities, that would give me cotan x. And so I can basically take that expression that was the fraction up there, and by separating it into the two individual fractions with that common denominator, separating that numerator, then I could simplify each fraction, and now I'm left with just cosecant x plus cotan x. Our next example is going to be another example with a fraction. But what we're looking at in this problem here is now I only have a single term. So trying to separate it like we did in example B over here isn't really going to work out. But what I do see again is that I have a trig function squared. And a lot of times when I have trig functions squared and I'm trying to simplify, what I'm going to do is jump over to my Pythagorean identities. And again, it might seem strange, but I might actually replace cosine squared with a bigger expression. So in this case, my numerator was that cosine squared x. And we've already seen that cosine squared theta is equal to 1 minus sine squared theta. So I'm going to replace this numerator, and I'm going to actually expand it out into 1 minus sine squared x over 1 plus sine x. Now, the interesting thing about some of our Pythagorean identities is when we rearrange them, they become a difference of two squares, because one is a perfect square, and sine squared is a perfect square, and we have that subtraction in between there. And when we have a difference of two squares, we can factor it by taking the square root of each term, and then in one parentheses do 1 plus sine x, and in the other parentheses do 1 minus sine x. And so I'm factoring that difference of two squares, and then I could keep that all over that denominator. Now, once I separate this up into two terms that are being multiplied together, I can reduce a product, or part of that product, with that down there. So that 1 plus sine x and that 1 plus sine x are going to cancel out, and then I'm just left with my 1 minus sine x up there. And there's nothing more exciting I can do with this guy, so we're just going to end it right there. All right. And our last example, what we're going to do is, again, look at another way that we can work with some of our Pythagorean identities. And here I see secant squared x minus tan squared x plus 1, and my goal is to simplify. So what I would do is I would just basically go to my Pythagorean identities and find either an identity that has secant squared in it or tan squared. And if we look at our Pythagorean identities, we can see, oh, look at that. Secant squared theta is equal to 1 plus tan squared theta. So I can, just like I did in that last example, I'm going to replace the secant squared x with that Pythagorean identity there. So I'm going to put 1 plus tan squared x there for where that secant squared was. And then I'm going to copy the rest of this problem out. And what I should notice now is that this positive tan squared x and that negative tan squared x are going to cancel. And all of this stuff right here is going to simplify to 1 plus 1 or 2. So there's different ways that we can use our Pythagorean identities to help us simplify. Sometimes we look for an entire identity and we replace it. Sometimes we use it as a piece of an identity and we replace it. I want to add in one more example to show one other algebraic technique that we can use. And so in this example right here, we see a lot of reciprocal functions. We have cosecant theta and we have cotan theta, and they're all, part of this function here with that random cosine theta at the end. And when I'm trying to rework these guys, a lot of times our first go-to is to rewrite using sines and cosines. So if I start here, I would rewrite cosecant theta as 1 over sine theta. And then if I work over here, I would rewrite cotan theta as cosine theta over sine theta. And that's being multiplied by that cosine theta, which I'm going to put over 1 just to show that it also can be written as a fraction. Once I have all of these pieces together, I'm going to clean up that numerator in that second fraction here. So what I have now is 1 over sine theta minus cosine squared theta over sine theta. So in this example, what we're actually going to do is rewrite this guy as a single fraction using that common denominator. And right now I can see both fractions have that denominator of sine theta. So that means that I can go ahead and write a single fraction, keeping that common denominator of sine theta, and I can subtract my numerators and put 1 minus cosine squared theta up there. So unlike our example B, where we took a fraction and we separated it and reduced the fractions that way, here I'm taking two fractions and I'm merging them together into one. And what happens here is, again, I see that 1 with that cosine squared. So anytime I see a 1 with a trig function squared, I'm going to go check out my Pythagorean identities. And if we go back and visit this first one right here, I can basically solve this guy, and I can have 1 minus cosine squared theta by subtracting that cosine squared theta over there. And if I do that, I'm going to find out that sine squared theta is equal to 1 minus cosine squared theta. So what I can now do is replace the sine squared theta in my fraction with 1 minus cosine squared theta. And so I can replace this right here with sine squared theta over that sine theta. And then this is having two sines in the numerator. This is one sine. They can reduce, and we'll be left with a sine theta down there. And so my final answer would just be sine theta. So these are some algebraic techniques that we can do. We can FOIL. We can combine fractions using a common denominator, or separate fractions into two separate fractions with a common denominator. And we can use Pythagorean identities to replace and simplify some expressions. All right, so your assignment is to work on those puzzle worksheets using some of these techniques and some of the techniques we worked on in class to simplify your trigonometric identities. And if you have any questions, please reach out to me.